folks. Time to do some experiments. We had a little hydrochloric acid over here on the right. Some color changes going on, of course. Yeah, we're going to see a shift to a red, orange, or yellow color there as I add the hydrochloric acid. Welcome aboard. Well, it's taking quite a bit. This must be buffered. Yeah, that must be a buffered solution for sure. All right, let's try adding some universal indicator to this flask over here on the left. It's kind of fun to watch it go in. I'm going to go ahead and turn up the speed, the stir bar speed, just a little bit so we can get the vortex going. I'll zoom in on it a little more so we can watch this happen. This is a cool effect. What's going on, AE Master? Welcome aboard. Boy, that must be a small little stir bar there. I got to really get that thing going to get... There it is. There's our vortex. Okay. Let me go ahead and add some universal indicator. How you doing there, Shane? Glad to have you aboard. All right, here's the universal indicator. You can see it's kind of a green color. Let's go ahead and add it to the flask. And it looks like my tap water, because that's where I got this water from. My tap water is neutral, pH 7. Anytime you see that green color, you know we've got a pH of 7. Let's add a little more. I want to get a little more color in there. There we go. Look at how that material kind of stays focused in the center of the vortex. Well, thanks, Shane. I appreciate that. So long. Thanks for hanging out with us for a little bit. All right, let's do some playing now. Let's do some experiments here. Let's get this light off. Add enough, the water will no longer be see-through. I don't know, man. I'd have to have quite a bit. I'd have to add a lot. All right. Okay, let's go add acid. I'm going to add a little bit of acid. We'll add 1 drop here. 1 drop of hydrochloric acid, same acid that's found in your stomach. We can do that, AE Master. We can do the CO2 experiment if y'all want. Maybe, Lord. So you notice I added 1 drop, just a single drop of hydrochloric acid. And it looks like our pH has changed from, well, here, let's add 2 drops. Here's the second drop. Boop, and it goes. And now we have, well, what's it gonna land off at? About a yellow color. So we went from pH 7, green, down to pH 6. So we went from neutral to acidic. I had a few more drops here. Here we go. 1, 2, 3 more drops. How you doing there, Frexles? I think we're down to pH 5 or so. Let's keep going. 1, 2, 3, 4 more drops. I'm adding hydrochloric acid. It's the same acid that's found in your stomach. It's just that this stuff that I'm adding, I'm wearing gloves, of course, because the stuff I'm adding is like 100 times more concentrated than what you find in your stomach. Oh, that'd be fun, Lord. If I had some Sour Patch Kids, I could use that. Okay, so right now we got a pH of 3. pH of 3, which is quite acidic. It could be lower than that, so pH 3 and below is going to appear red. pH 10 and above was going to appear violet. Let me go ahead and add, let's go ahead like 2 drops of sodium hydroxide. That's a base, so it should increase the pH. So we're going to go 2 drops. 1, 2. You can see that violet color grow in. And the base, oh, there it is, man. We got the rainbow. Come on, man. We got the rainbow. That was beautiful. Oh, that's just so beautiful when that happens. Anyway, I've added base to the mixture that was acidic, okay? And what that tells us is, you know, that we went from pH 3 to pH 6 as I added base. I'll go ahead and continue to add base. Let's add another drop here. Oh, I love it when we get the rainbow. And you'll notice, as soon as I add the base, you see like that violet color grow in there. That's because, you know, the base is like pH 10 or higher. And then as the acid that's present and the base that's present, as they react, they neutralize each other. So when you see, like here at the top, I'm going to add a little bit of acid. You'll watch it go red when I add the acid because, you know, the acid is like a really low pH. But then the acid and bases that are present, they react with each other. And what happens is they neutralize each other. So, you know, if I add a pH 3 and a pH 10, they'll bring each other closer to the middle. Right now we're at a pH of 6 or so. Greg, I could, but I think it ruined the live in about 10 minutes because one of the indicator dyes, one of the pH indicator dyes is an acid. Excuse me, is a laxative. Right now I'm adding acid to the flask, and that's lowering the pH to about 3. All right, so there we go. We're down to about pH 3. Now I'm going to add, we're going to try adding those 2 drops of base. Now remember, when I add the base, you're going to see a big flash of violet because base is high pH. But then the purple and the violet, they're going to neutralize each other. I wouldn't do it, Greg. Here we go. We're going to add 2 drops of base. We're also going to see a bunch of different colors as the acid and base neutralize each other. There goes 2 drops of base. Let's see what happens. Oh, we didn't quite get the nice flash of that. Let me add a 3rd drop. See if we can get that flash of the rainbow. Boy, we got a nice, beautiful rainbow there. Frex, no, you wouldn't want to drink this. One of the dyes is a laxative. One of the indicator dyes. There it is! We caught a flash of the rainbow, baby. Come on now, that's beautiful. Is it true that if you put base and acid together, it produces hydrogen? AE Master, when you add a base and an acid, it makes salt and water. And the particular salt that is produced depends upon the particular base that is added. Well, both the base and the acid that are added together. Let's go ahead and add a couple drops of base here. So, you know, that's why we say it's a neutralization reaction, because the acid and the base, they neutralize each other, and you end up with a salt, which is either neutral or closer to neutral, and water, which of course is neutral. I see that. You got a lot of brave people out there. Trust me, you wouldn't want to do it. It would really ruin your afternoon. When I'm talking about a laxative, it's a really good one. A stable rainbow. We can do that, Lord. Give me a second, though. We're going to have to set up a different beaker. Hello there, Crescencio. We are going to try to get a stable rainbow. You're just going to have to give me... Oh, we got a little flash of one there. That's cool, AE Master. I love that experiment. What's going on, Techno? We got a fellow chemist in the chat. Good to have you aboard. Okay, let me get a second flask going here. Somebody wanted me to get a stable rainbow. So we do that by setting up a static flask. So let's do that over here. Chandra, pure O2? I bet it was more air, huh? I'm not that kind of chemist. Okay, what do we got here? Let's add, I'm gonna add distilled water to this flask over here on the right. So here we go. In goes our stir bar. All right. Let me add a little bit of acid over here on the left while we're waiting, so we can see some color changes. While I pour in some distilled water over here on the right. See if we get a vortex going. You can see there it's distilled water. That's what I added. Okay. All right, while this one's getting ready, I'm going to go ahead and add some base over here on the left. Can I use CO2 in the right size neutral? We can do that. I can try to remember to do that. It'd be cool if acids and bases came to work already in their pH color range. It'd be easier to train new chemists. Matthew, I apologize. I'm having trouble understanding what you're saying there. It's probably because I'm doing too much and not paying it. Let's see. Acids and bases came into work already in their pH color range. Here we go. A couple more drops of base over there on the... Oh, we got it! We had a flash of the rainbow. Okay, let's go ahead over here on the right-hand side, and we're going to add some universal indicator to the distilled water. So here's my universal indicator. I just buy this stuff online. All right. We're going to add the universal indicator so you can see. There it is. You see that nice, beautiful green color. Let's go ahead and add it to our vortex. And you can tell that the green is changing to a slight yellow color. That's actually expected because pure water that's exposed to the atmosphere will be slightly acidic. No, it's not the same acid as soda acid. I can make some of that though, Frex. So regular water, pure water, I should say, that's exposed to the atmosphere, if it's purified, will be slightly acidic because carbon dioxide from the atmosphere dissolves into the water. And CO2 in water is slightly acidic. That blue on the left is nice there, soft. I agree. Look at that. We got beautiful colors. Beautiful colors there. Okay, I'm going to add a little bit of acid over here on the left-hand side. So let's go ahead and pop them in. And you'll notice that it changes to a red color. That's indicating a lower pH. We're going to, try to get that down to about a pH of 3. Thank you there, Ivana. So yeah, here's the pH scale right here. You can see over there on the left, we got like a pH of 3. Over there on the right, like a pH of 6, right? Okay. Now I'm going to add some base to this flask over here. And when that happens, the acid and the base, they react with each other. Watch here first over here on this side. Watch what happens when I add some base. This is straight up base. Boom. You see that violet color? Oh, down there at the bottom, you can really see it. And then it's reacting and going through. So yeah, the base happens to be violet, like strong base. pH 10 or higher is going to be violet. pH 3 or lower is going to be acidic, okay, and red. And then when you add base to this side, the acid and the base will neutralize each other. So when I first put the base in, you'll see that violet color. And then the acid and base together will react. I got a little bit more. We want a little bit more. I want to try to catch that rainbow. Come on, baby. Oh, there it is. We had a little flash of rainbow going on. I love that. Yeah, man, it's just beautiful, right? Because see what's going on there is the pH 3 acid and the pH 10 base, they react and they neutralize each other. But because, this is not a static environment, it's a dynamic environment. Hey, Fluffy, thanks for the gift, man. Appreciate that. Hello there, Jonathan. So yeah, because this is a dynamic environment, you're going to get neutralization, which means the 3 and the 10, they're going to neutralize each other and bring it closer, to 7. But it's going to happen at different rates in different regions, and that's why you get all the different colors. Let's do that one more time because there's so much stinking fun. I'm going to go ahead and add a bunch of acid here. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. Hey, hello there, Megan. Okay, and now I'm going to add the base, which you remember is this violet color. And when these two react, they neutralize each other. So here we go. Let's add some base. Hello there, Godzook. And we're going to add like 2 drops here. Let's go like 3 or 4. Let's see if we get that rainbow. Come on, man. Come on, man. I think I added too much. Yep, I sure did. We're going to have to try that again. Let's add some acid here, get it back down to pH 3. It just works better when I start from the acid end. The purple matches my gloves. Indeed, look at that. Come on now. Let's get logarithmic. RJJ is winning the comments so far. Fluffy, thanks for the gift. Can I try to make one back to red? You got it, Fluffy. Fluffy wants it red. We're going back to red there, Fluffy. Fluffy just dropped 2 pounds into the chat. I appreciate that. Here we go. Come on, there's your red. That's for Fluffy. Fluffy dropped 2 pounds. I appreciate that. Seriously. Okay, somebody asked over here, they want to get the static rainbow. Here's where I'm going to try this. We're going to do this for Fluffy. We're going to do both red for Fluffy. Come on now. Fluffy donating up the scene here. There we go. That's not quite red enough. I'm going to add just another squirt. It could be the lighting. So I do backlighting. There's like these lights in the back that I use to really make the colors pop. So there's a little bit of, yes, it's on a magnetic stir bar. There's a little bit of camera juice art happening around here. Here we go. Let's add another little, oh, look at that red. Come on now. That's really red. All right. Megan, what I am doing is I'm adding acid or base to universal indicator in water. And universal indicator shows these pH values, these colors at different pH values. Thank you there, Rick Star. So like right now, everything's looking red. It's acidic, okay? So what we're going to do is I'm going to start adding base over here. When that happens, the acid will be neutralized. So the base, which is pH 10, and violet, will react with the acid, that's pH 3, and they'll neutralize each other. But what's cool about it is it does it at different speeds and in different regions of the vortex. So here we go. We're going to add, I'm going to go like 3 drops of base. 1, 2, 3. Let's see what happens. Come on, let's see if we get a rainbow. Come on now, there it is. We got a little bit of rainbow action going on over there on the left. I love it when that happens. So beautiful. And somebody said, see if we can get this to go static over here. So we're going to try this. So what we're doing there, hello there, Bryson. Hello there, Xavier and Calvin. Hello there, Kevin. What we're going to do over here on the right, you'll notice I've turned the stir bar off. And I'm going to add, let's go with like 2 drops of, let's go 3. 1. So you can see the base in there. 2, 3. And we're just going to let that kind of just develop, okay? So what's going on here is the same thing we saw over here on the right, excuse me, the left, except, you know, it's no longer stirring. It's going to be static. We're just going to kind of watch and see what happens. I love it too, AE. What does it mean when it's acidic? Fly wolf. What we mean by acidic is we mean that the concentration of a particular ion in the solution is very high. And that particular ion, we call it, hold on a second. Oh, let me get something to write on so I can, let's see. Here we go. It is what we call the H plus ion, or the hydrogen ion. Let me write it right here. Here we go. The H plus ion, looks like that, okay? When that H plus ion is very high, the acid I'm adding is hydrochloric acid. There you go, RI. We got a chemist in the chat for sure. When the H plus ion concentration is high, then your pH is low. That's just the way the mathematical definition works. I'm going to add a little bit of acid over here on the right. When the concentration of H plus is low, then you have a base. And concurrently, with a low H plus concentration, there's another ion called the hydroxide ion, and that's this bottom one. So when hydroxide ion is high, we say the solution is basic. When the proton concentration is high, we say the solution is acidic. What's cool is if you add these two together, what do you make? Come on, man, what happens if you add H plus and OH negative together? I think you can see it. You make good old, come on, man, what do you make when you add these together? There you go, New York Jets. New York Jets, Cypher, Gluteal, H2O, Alwi. Hello there, Sandra. All right, you got it. Alwi, you got it, man. You make neutral. I am, Luke. I definitely am. Why do we all sound the same? I don't know. Maybe it's just because that's how smart people sound. All right, Jay. Here we go. We're going to add... This one over here on the right messed up. This one over here on the right messed up a little bit. So I'm going to go ahead and stir this. I added way too much base. We're going to try this again. Let me add... dihydrogen monoxide, Damien, right? You got it, Sandra. Hey, thanks there, Cypher. Appreciate that. Thanks there, Justin. Appreciate the kind words. Okay. Do I do formulaic equations too? I'm not sure what you're saying there. Hey, DNA, welcome aboard. Here we go. I could watch this all day. You should do a video on emulsifying polar and nonpolar liquids or liquid density. Hey, 95, check out my video on the density bottle. Thank you for the subscription. It's ITZ. Man, I keep forgetting AE. Okay. Over here on the left, let's go ahead and add in a couple drops of base, see if we can get that rainbow going. Come on, man. Oh, I think we got it. I think we got it. Little flash of rainbow. Thanks, sir, Kinetic. Love the name, Kinetic. Am I going to do physics videos? Luke, I have a couple of them. I have a couple physics videos. I'm a physical chemist, so basically I'm a chemist that studies chemistry. A physical chemist is someone who studies chemistry through the eyes of physics. Right now, I'm adding drops of base to this flask over here. Okay, what experiment is this? Let's back up. We got a couple of new people in here. Let's talk about what's going on in here. And believe it or not, in both flasks, I have the same thing. I have water and something called universal indicator. It's also known as rainbow indicator. And what rainbow indicator does is it shows you different colors at different pH values. So over here on the left, you'll notice that kind of looks like what? That looks like a pea green, like a green and a yellow. So that means, you know, if I go here to my scale, we're going to have a little bit of yellow, a little bit of green. And so my pH is somewhere between 6 and 7. It's almost neutral, but just a little bit acid. Over here on this flask on the right, we got something really cool going on. At the top of the flask, we have pH 3, red, and at the bottom, we have pH 10. Now, what's crazy about this is the difference in proton concentration, because that's what pH measures. The difference in proton concentration between these two layers is 10 million times different. Now, how do I know that? I know that because of the pH scale. The pH scale goes on powers of 10. The way it works is your lowest pH is going to, your pH 3, that's going to be the most acidic. A pH of 4 is going to be 10 times more acidic than a pH of 3. A pH of 5 will be 100 times more acidic, more basic, sorry I said that. A pH of 3 will be 10 times more acidic than a pH of 4. A pH of 3 will be 100 times more acidic than a pH of 5. So every step in the pH scale goes by powers of 10. So the difference over here between red and violet, here we go. We got 10, 100, 1,000, 10,000, 100,000, a million, 10 million. The difference in acid between the top and the bottom is a difference in concentration of 10 million times. Pretty cool. All right, let's get back. We had enough of that math stuff. Let's get back to doing some experiments here. Come on now. I love some chemistry too here. Here we go. In the right beaker, why is there no salt formed? There is salt formed. Raghov, there is salt formed. I'm adding acid to the flask on the left. The acid that I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that this stuff is like 100 times more concentrated. How to cook math. Do your math homework. Hey, what's going on there, Sharky? Thanks for the comment. Thank you there, Robert. What makes the rainbow or each color in the acid? So, Frex, what makes the rainbow are the different indicator dyes. So they're different indicator dyes in the universal indicator. And each of them show different color formations at different pH values. Has anything ever blasted during an experiment I've done? Yes, R.I. Sorry, Sultan. I don't mean to ignore you. Thank you there, Zion. The blue color is heavier than the red. I think so. Yeah, I agree. This is really cool the way those two layered like that, man. Oh, Cesar, I love doing science videos, man. I'm never going to stop doing that. Thank you there, Jamie. Come on, Sharky boy. We all got whatever we're doing on our channel. Keep doing your thing, man. Keep doing your thing. One of the indicators, Caleb, is phenolphthalein. One of the 4 that is found in the universal indicator. Saman, I agree. It's a little more violet than blue. What are we doing? What we're doing. Thank you there, Bob. I appreciate the subscription. Me too, Robert. Thank you there, Robert. I agree. It's a beautiful color. Westnam, if you look through my shorts, I do have, and my long-form videos, I do have a video where I do some BZ reactions. Okay, here we go. Let's go ahead and add a few drops of base over here on the left. Can I make it yellow and green, Sultan? I'm going to try it right now. This is for Sultan. I am not heating. I'm just mixing. Thank you there, Bryson. So long, Caleb. Good to have you around. The magnetic plate is called a magnetic stir plate. Pretty much there, Nate. Pretty much. So someone asked for a yellow-green color. I got you right there, baby. I got you right there. I think they do look like good drinks, James. The issue is one of the dyes in here is a really good laxative. It used to be the main ingredient in X-Lax. There you go, Sultan. There you go. All right, let's make this thing over here red. Thank you there, Sharky Boy. I love it. Is that popcorn? I can't tell. It looks like popcorn. Hey, I'll tell you what. You've been following along. We're going to mix this up over here. If you've been following along, you know what color that's going to make when I mix it up, huh? Can I make it colorless? See, JP, you're going to have to forgive me. I'm getting my chemistry teacher hat on. It is clear, right? Clear just means can you see through it or not. So this is red and clear. I know what you meant, though. You meant can I make it colorless again? I'd have to remove the dyes to do that, and that's a really tough process. NO2, gluteal. Hey, thanks there, Nate. A radiant gold with blue. I can try that. Can I do a rainbow in reverse where I add acid to a glass full of basic water? That one's tough, but we can try it. If one is too reactive for heat, how would you mix it efficiently? I apologize, Solval. I don't understand the question. I'm so sorry. How is it a whirlpool, Sultan? It's just a magnetic stir plate. What happens if you heat it up? That's a good question, JP. I don't think it changes much when you heat it up, but I've not really looked into that carefully. Okay, here we go. We're going to play a game here. We're going to get a little action going on. If you've been following along, you should be able to guess what will happen when I mix these two together. Although I don't know. See, let's talk about it. So, you know, the top is pH 3, the bottom is pH 10. If there's an overwhelming amount of base, when I mix this, everything is going to go purple. If there's an overwhelming amount of acid, when I mix this together, everything is going to go red. If they're perfectly balanced, it's going to be green. And if it's off in any manner, it might be, you know, if there's a little more acid than base, it'll be orange or yellow. And if there's a little more base than acid, it'll be blue. So drop in the chat what color you think this is going to be when I mix it. I'll tell you straight up, I am used to seeing this be violet when I do this. The reason why is the base tends to be more concentrated. So just to cheat a little bit, I'm going to go ahead and add a little bit of acid to the top. I'm going to add like 3 drops. Now let's go 4. Okay, so I don't know what's going to happen now that I've done that. No clue. I'm still going to guess it's going to go violet, but oh, wait. Let's just watch that for a bit. Look at that. It's like, come on, man. What's going on in there? That's pretty cool. It's like the acid is penetrating the base and neutralizing it. So, yeah, put the heart emoji in the chat. What color you think this will be when we mix it. Bryson is guessing blue. Abdalek is guessing 5. We need to add some glitter. AE Master says a greenish yellow. Donald says a blue-green. Let's add a little bit of base over here on the left just while we're watching that. We got some violet. Thanks there, Science Dude. Welcome aboard. Westnam saying yellow. Muhammad looks like a blue. We got all sorts of... Jet, I can't do that. I don't have the materials for it. James is saying violet. We got a lot of violets, man. We got a lot. All right, Team Yellow. Come on, get your votes in. Get your votes in. Don't lie. We can go back in the chat and check. All right, let's do it. Let's mix it up. Here we go. 1, 2, 3. Oh, let's see. I'm thinking yellow. I'm thinking yellow. Orange. Who guessed orange? Who guessed orange? I tell you what, that's really rare to get orange. I rarely see that one happen. There we go. No, Nikki, I save it. I acidify everything, and because mold grows in it if it's neutral or slightly basic. Lord, I know a little bit about convection. I do wonder if something that's going on sometimes because yellow is basically orange. I forgot what I was saying. Too much going on in my head, man. The machine, Sultan, that I'm using is called a magnetic stir plate. All right, let's acidify these. I'm acidifying these by adding hydrochloric acid. It's the same acid that's found in your stomach. There we go. So now the pH is 3. Hello there, David. pH is 3. I'm going to add some base, which is pH 10. So when I add the base, you're going to see drops of violet go in, and then they'll neutralize each other. And they do it in such a beautiful way. Let's check it out. Here we go. Let's add like 3 drops over here on the left, 3 drops over here on the right, and watch the magic. Come on, let's go double rainbow. Come on, man. Oh, no, too much base over there. I way overdid it. Let's try it again. Here we go. What's going on, David? We're going to try this again. So I'm adding acid to the flask on the left. That's going to make it a pH of about 3. All right. I'm going to add acid to the flask on the right. You'll notice that the color shifts to a red also. You know, that's going to make our pH drop. So let me just put this right here as I'm doing it so you can see what's going on. Over here on the right, I'm adding drops of acid. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. That's a good idea. You know, Nate, you'd think I'd have done that this many times into the live. I've done this live so many times. That's pretty cool over there that's pretty cool over there on the right, man. Ultra, I have done it. I'm just having trouble getting it today. Thanks there, Tracy. Hello. Okay, we got 2. Hey, let's do that, Sharky Boy. Sharky Boy just inspired me. Drop your favorite science emoji in the chat. Okay, let's try this now. I'm from the United States, Sultan. Here we go. We're gonna add. Let's do 2 drops over here on the left, 2 drops over here on the right, and see what we get. Come on, man. We got the rainbow on the left. We got the rainbow on the left, and I'm telling you, over there on the right, that just turns to violet like crazy. Random VR. We got some DNA. Robert, the geologist. Sultan, the chemist. I'm loving the emojis coming through. Saman, I apologize. I have no idea what that emoji is. Thank you there. Appreciate that. Thank you there, Muhammad. Hey, we got a Petri dish. Come on now. Come on. I see you, Zozo. Okay, let's try her again. Tracy the chemist. Okay, here we go. I'm going to add a drop over there on the right. Come on, give me the rainbow. You know, I wonder if that stir speed's just too fast. I think we got it. I think we got a little bit of rainbow. But I do think if I turn that stir speed down just a bit, I think it may help. I think it's mixing too fast. Lord, they do have, sometimes they have heat stir plates. These are just stir plates. Thanks for all those science emojis. That was fun, man. Here we go. 2 drops of base with a slower stir speed. Too much, man. Too much. How do I make it basic? Science dude. I'm adding sodium hydroxide 20% by weight, and that's what makes it basic. Thank you there, JJC. Thank you there, Sharky Boy. Let's get this acidic. What's the total alkalinity of the glasses? You know, I don't know, buddy. I do not know. Wessam, yes, it will always be transparent. Oh, we got a biologist, Denise, the microscope. I'm loving it. Here we go. The mixtures are called magnetic stir plates. Come on now, let's get the rainbow over here. I'm tired of this. And let's do it over here on the left. Come on, let's do it. Come on, let's do it. I'm still too far off. Angela, the colors apply to the pH scale. It applies to these. So like this. Like that. Okay, Sultan. Good to hear. Random. I could maybe do that by adding an enormous amount of the universal indicator. So anytime. How is this happening? So what's in each flask is something called universal indicator. Universal indicator is also called rainbow indicator. It displays these colors at different pH values. So right now, we can see that both flasks are like a pH of 3, right? Because they're red. Now, when I add, here I'm going to add a drop of base over here on the left. And it goes, you'll notice it goes violet right away. And then it ended up just a little bit less red than it was before. That violet comes from a base being added, and then the acid and the base, they neutralize each other. Now, there's a heck of a lot more acid in the base than I added, and that's why pretty much the base just consumed all, the acid consumed all the base. I'll add another drop of base. Let's go one more over here on the left. In goes the violet color, then the acid and the base react. Oh, we got a little flash of a bunch of different colors because it takes time for everything to react. You'll notice the violet is being maintained there in the center. It stays there for a while. But aha, what do we notice? We notice that as I added the base to the acid now, the pH has gone up to 6. So we're a lot less acidic than we were before. In other words, the base neutralizes the acid. Let's add another drop of base and see what happens. And now we can see that the base has overrun the acid, and now the mixture is slightly basic, like a pH of 8. And there's more base in there than acid. Well, maybe pH 7 there. Okay, let's add another drop. How do they form in a real-life ocean? How do those funnels form? Heck, I don't know, man. Do my favorite color? Man, I don't know. Okay, let's try this. Let's see if we can't get this to neutral here, folks. You know what? AE, I think you're going to like this better. I'm going to go ahead. AE's been asking this for a while. I'm going to go ahead and I'm going to add enough base. Okay, so this is now quite basic. What I'm going to do now, AE Master's been very patient, so I'm going to go ahead and do this experiment for AE Master. What I'm going to do is I'm going to add some of this pH 10 water to this flask. Hopefully I don't mess it up here. Yep, I got her in there. Okay, there we go. So you'll notice I have, like pH here. Let's do a little more. This is going to take me a little longer, but I don't know how long this will take. Okay, so we have a pH 10. I'll put this over here so you can see the pH scale. And now what I'm going to do to this system that it's got a lot of base in it. Oh, Fluffy, come on, man. Fluffy dropping 2 pounds. I apologize if you're asking me to drink it there, Fluffy. It's not going to happen. Okay, so AE Master has been asking, can I put some CO2 into the flask? And that's exactly what I'm going to do. We're starting here at pH 10. I want you to watch what happens as I exhale through this straw into this flask. It may take me a little bit, so hang in there with me. And while I'm doing this, I can't read the comments. I'm just not going to be able to do that, so you'll have to forgive me. And I got to make sure I don't step on my cords and move everything around. Hopefully everything looks okay. There we go. Okay, here we go, baby. Let's blow into this and see what happens. Ah! That's my background. That's supposed to make everything look pretty. I got to worry about that stuff. It's YouTube. Here we go. 1, 2, 3. Oh, I'm noticing something, are you? Sure enough, as I exhale into the flask, the carbon dioxide from my breath has lowered this from a pH of 10 to about a pH of 8. Let's keep going. Splashed a little bit on me. That looks like it's going a little lower. Let's keep going. Looks like I've neutralized the base with the exhaled breath from the carbon dioxide of my exhaled breath. Let's keep going. Whoo! Oh man, the contents of the flask are turning green, but my face is getting red. Let's keep going. So there you go. You can see from that particular experiment that carbon dioxide is indeed acidic. You can tell that because I neutralized, not only did I neutralize the violet color, but I also made it just slightly acidic. It's like a little bit yellow-green. It's not just green. Thanks there, John DC. Okay, let's pour this back in and get back to doing that other experiment. Oh, I'm not that kind of chemist. Asmit. However, if you do like Breaking Bad, you guys are going to love this. You got to check out my short, my YouTube short that's coming out next Saturday. You're going to love it if you love Breaking Bad. I promise you. You're going to absolutely love it. And I'll guarantee you it's an experiment you haven't seen before. I think it's actually a new demonstration that I've invented. As far as I know, no one's done it before. So anyway, be looking for that. Be looking for my my YouTube short that'll be coming out next Saturday. You know, I do a little Breaking Bad cosplay. It's a lot of fun, man. The video was just a blast to make. The cosplay was fun, and the experiment is just dynamic. It is so stinking cool. You're not going to want to miss that. And hey, if you don't like it, let me know. And if you do, you can tell me that too. But I really think you're going to enjoy it. No, that's not going to be what I'm going to do, Westnam. I will tell you this, though. I'll let you all know this here. You guys heard it first here. I won't be making that. However, I will be making blue crystals. So there you go. I will be making blue crystals. That's all I'm going to tell you, all right? Oh, man. All right, man. I'm getting to the point where I'm running out a little bit of steam. So we are going to pretty soon turn the camera around like I do near the end of the live and I talk to folks. So if you don't want to see a 57-year-old man in his basement, now's the time to get out of the live, okay? Thanks, Asmit. Let me know how it goes. AE Master, I usually do my lives on Sunday afternoon, sometime between, you know, this time and maybe it's a little early. Sometimes I go a little later, but this time I decided to go a little bit earlier in the day. No, that's not what I'm making. All right, so long, Sharky boy. So long, Sharky boy. All right, we're going to turn around, say hello to everybody for the end of the live. We'll talk. So long there, Jabril. Love the name, man. Love that name. What's the max pH possible? Science dude, what a great question. I don't know. John DC, what's occurring right now is I'm adding either acid or base to both of these flasks. Both flasks contain universal indicator, and universal indicator changes color depending upon pH. That's what's going on. Hey, thanks there, Tracy. Hope to see you next time. Hope you enjoy my YouTube short that'll be coming out next Saturday. All right, let's flip her around. Let's talk to folks. Again, I'm warning you. I'm warning you. Here we go. Say hi to everybody. How we doing out there, folks? I love the name 1,4-dimethylcubane. It did look like the Northern Lights. Hello. Hello, Southern. Hello, Tracy. It is not safe to drink, Sultan. One of the dyes is a laxative. Hello, Science. I do have a merch. You can just go to my channel and you can click on there and there's some goofy stuff that I have. Hey, thanks there, Westham. Thanks there, John DC. I appreciate that money. A lot of clean living. A lot of clean living. No, heck no, man, I wish this was the merch. Come on, that'd be awesome. I can show you what the merch is. Let's show you this. Just a few of them. Let's see. I got little sayings. One of them, this is probably going to look backwards. Yeah, but it says, I've never had a failed experiment, only new observations. That's one of them. One of them's got, if you like this. I don't know why anyone would want a t-shirt that says Tommy Technetium. That's why I made all these other things. My favorite one, this one. I've got this one. So many experiments, so little time. Man, that's my motto right there. I tell you what. Actually, this is my motto. I've never had a failed experiment. You put that on a mug, you put it on a t-shirt, and the one I'm getting, I love this one. It says, true patriots use Kelvins. If you know, you know. Hey, check you next time there, Casey. Thank you there, Willett. Yep, the Texas married. Hey, thanks there, science dude. Thanks there, Mark. What do I think about methylene blue? It's a great redox indicator. That's what I think about methylene blue. But if people touting it for health stuff, come on, man. Come on, man. Hey, how you doing there? Nothing. Thanks there, Jen. Thanks there, sad kid. Laser glass, trust me, bro. Thanks there, Philadelphia. Ah, that's funny. So I majored in, I was a physical chemistry. So long, good. I hope you get a good rest there, Westnam. Dead soul, I'd say hydrogen. Thanks there, sad kid. Thanks there, format. Appreciate it. Hey, we got someone in from Germany. That's my ethnicity. I'm like 8 out of 8 of my great-grandparents are German. Kind of, maybe. Will it? If you like that thing, you're going to love the live I have coming out next Saturday. Can I do some experiment on thermodynamics? Always. Like always, right? I mean, everything is driven by thermodynamics. So long there, Fianfa. I am. Yep, I'm a married man. Elliot McLaughlin wants a shout out for their channel. Hello there, dead soul. What's my favorite element on the periodic table? You let me know yours. I love hydrogen. Hydrogen's so long there among us. I love hydrogen. Thanks there, Willett. Hey, we got someone from the United Arab Emirates. Awesome. Awesome. Daki from Germany. I'm loving it, Mahan. Chemistry is definitely awesome. Hey, thanks. Come on, Jen. That's awesome. So Willett likes mercury. What does hydrogen trioxide do? I think it doesn't exist. Although maybe ozone can pick up a hydrogen atom, but I don't know, man. Astatine. We got to vote for astatine. We got someone from Denmark. What's my favorite chemical reaction? Whichever one I'm doing at the time, baby. We got an electronic engineer, man. So Sparkle. SI units, of course. Oh, silicon. I thought silicon, of course. Hello there, Tommy. Hello. I'm sorry about that, sad kid. Gold's a good one. Gold is definitely a good one. Hey, we got someone from MIT. Come on, man. MIT has entered the chat. That made my day right there. Come on, man. We got science dude from Iran. What's on Ganymede? I don't know. I'd have to look that one up. That's funny. Bacon soda vinegar. How to add CO2 to water. Just exhale into it. We got someone liking some gallium. I love some gallium. Sorry, Mahan. I don't know what that is. Hey, thanks for letting me know there, cats. We'll go off screen. Cats just let me know I got boogers in my nose. Thanks there, cats. Nobody wants to see that. Still not better. I'll just keep my nose down. How's that? We got a nitrogen. We got a phosphorus. Hello there, Deb. Elliot just started a channel. Thanks there, sad kid. Indium. Counting from the United Kingdom. Someone from Brazil. Thanks there, Danny. Hello there, Deb K. Omar, I'm Tommy Technetium. You check out my channel. I do a lot of science education, a lot of science fun, a little bit of science humor. and some new experiments you may not have seen before. Hey, we got someone from Stanford. Holy cow, we've got MIT and Stanford in the chat. Come on, man. And I got my PhD at the University of Michigan. So I know it's not quite Stanford or MIT, but not too bad. We're top 20, top 15 in chemistry. All right, folks, I had a good time with you today. Good time with you today. Enjoyed hanging out. Tom Brady, that's funny. All right, folks, great hanging out with y'all. Fun doing some experiments. Had a great time. I usually do my my lives around this time or a little later on Sundays. So, have a great rest of your day. Remember to enjoy that beauty of science. It's all around you, man. It is all over the place. Anytime you go outside, you see the sunrise, you see the moon, you see the stars, you see the clouds in the sky, you hear the rustling of a brook. Oh, you drink a nice cold glass of water. All of that is the beauty of science. And I like to say that, excuse me, the universe is always having a party, but science gets you on the guest list because it helps you understand the beauty and the wonder of the phenomena that you're experiencing. We'll see you next time, folks. So long.